The Earth exists within a vast magnetic cocoon. A force field that for billions of years has sheltered us on our journey through space. But now, scientists have made a startling discovery. It seems there's a storm brewing deep within the Earth. A storm that is weakening our vital magnetic shield.
It's that buzz when I'm full of your sweet magnetic pull.
The Earth's magnetic field has been our protector for millennia, and now it appears it's about to go away.
It's how
The Earth's magnetic field is getting weaker rapidly.
We cannot guarantee that the magnetic field of the Earth is still going to be there 1,000 years from today.
Is our invisible shield about to disappear?
The question is not if that's going to happen, it's when that's going to happen.
Could the Earth really lose its magnetic field? And what will happen if it does? Up next on Nova, Magnetic Storm. The magnetic field is created deep in the Earth's core. It streams out near the South Pole, loops around the planet, and then runs back into the core near the North Magnetic Pole. This is the Earth's protective force field. Without it, we'd be in trouble.
It protects us against radiation from space. It's a little bit like being in the pod here. This shields us from the weather on Earth. The magnetic field of the Earth shields us from space weather and space radiation.
Space weather is nasty. The winds that blow through the galaxy are winds of radiation, some of the most harmful from distant exploding stars.
But there is another source which is much nearer, which is our sun. The sun itself is a thermonuclear furnace, and this flings off huge amounts of dangerous material in very large explosions. In some cases, it's about the same mass as Mount Everest actually coming towards us.
Every few hours, the sun ejects billions of tons of electrically charged particles, the solar wind. Often, the Earth lies directly in the path of this onslaught. But magnetism deflects charged particles. This means that the solar wind is unable to penetrate the Earth's magnetic shield, and so flows harmlessly around the planet. The only visible signs of this drama far above our heads are the northern and southern lights, produced when solar particles trapped in the Earth's magnetic field are dragged through the atmosphere toward the poles.
Now, we're lucky on the Earth we have the magnetic field which deflects the particles and protects us. But if we lost the magnetic field, there would be nothing to stop the radiation bathing the whole of the atmosphere, and the effect would be much more dangerous.
But just how dangerous? What would be the ultimate consequences for planet Earth if the magnetic field were to disappear altogether?
So that's basically similar.
Mario's team now knew that Mars had once had a magnetic shield, which it must at some point have lost.
Well, not most of them, but 30.
Scientists suspect that the young Mars was in many ways an Earth-like place, with a thick atmosphere and oceans which may have harbored primitive life. But then, around 4 billion years ago, the planet entered a catastrophic decline. Gradually, the atmosphere and oceans of Mars mysteriously disappeared. 4 billion years ago is when Mars was beginning to lose its water and atmosphere. Though not all scientists agree with him, Mario is convinced that the timing is not just a coincidence.
If we shut down the magnetic field, then the solar wind has direct access to the atmosphere of Mars. Then we have a process which is equivalent to the erosion in a desert. The wind blows and it blows the sand away. In this case, the sand are atmospheric particles. Slowly but surely, the atmospheric gases, which includes water, are carried away and are lost to Mars.
The loss of its magnetic shield could well have meant death for the red planet. Exposed to the wind of radiation from the sun, over millions of years, its atmosphere was gradually blown away, leaving the sterile world we see today.
If we were to turn off the Earth's magnetic field, the same process would occur. The atmosphere of Earth would be exposed to the erosional effects of the solar wind, and it would be slowly carried away.
The fate of Mars suggests that without the protection of its magnetic shield, the Earth could also become a dead planet. Which makes it all the more disturbing to learn that our own magnetic field is fading so rapidly.
But what generates the most concern by far is HARRP's ability to tamper with and punch holes in the ionosphere.
The thing that one of the Air Force documents points out is that they want to use this heater to create enough energy in the ionosphere to get a runaway effect up to the next stabilizing level, whatever that might be.
It's precisely whatever that might be that worries Dr. Patrick Flanagan, a physicist who believes the ionosphere is extremely fragile.
The ionosphere is a chaotic system that is on the edge of instability. So the trigger point for HARRP would be that energy and that frequency which throws the ionosphere into chaos. In other words, it would be that point which throws it over the edge.
For example, it is believed that a hole in the Earth's ozone layer has caused an increase in infrared radiation, contributing to the melting of the polar ice caps and forcing New Zealand children to wear protective clothing to school. Flanagan and others believe the potential danger from a hole in the ionosphere is much greater.
It could create a change in the ionospheric shield that protects us from cosmic radiation. We're worried about the ozone layer. The ozone layer is nothing compared to what HARRP could do. You know, we're worried about ultraviolet light. That's just a very harmless ray compared to some of those energy streams or particles that are coming from outer space that are being deflected by this natural shield around the Earth. And this is what HARRP wants to play with.
Critics worry that HARRP has been placed in the hands of too few, and that international debate is necessary to fully explore all the potential dangers that this project may soon unleash, a proposal in which the Air Force has shown little interest to date.
Once we open this box, and it is a veritable Pandora's box, we're not going to be able to close it. And of course, once you acquire a technology, you want bigger and better aspects of it. And then we come into the questions of whether or not, if we go big, if we go better, if we're going to cause damage to our planet.
Proponents of HARRP insist the danger has been grossly exaggerated. The project continues to move forward as scheduled and will be fully operational by 1997.